Okay, good evening everyone, and welcome to the Society of Motor Manufacturers and Traders, who very kindly lent us their venue for the evening. And welcome to a talk by Alan Trevenna about about automotive audio, or as it used to be known, the British hi-fi industry. There's some quite exciting things happening there, and I'm sure he'll enlighten us. He's from Jaguar Land Rover. Few housekeeping things before we start. If there's a fire, just follow the signs and we meet in an alleyway behind the building. That's my legal responsibilities out of the way. I will, as usual, be passing our clipboard around. If you please add your name to that. We need it here for fire regulations as well as the usual housekeeping, so it's important you sign up. There won't be a lecture next month. There's no July lecture and there's no August lecture, so we're taking a summer break. We'll return on the 10th of September, again the second Tuesday of every month. So we'll be having a lecture that'll be presented by Sony. We haven't got a venue yet, but we will have within the next few weeks, so keep an eye on the newsletter, please. And what else is happening? Now, I think I've been through all my duties and I've said everything I need to say, so with no further ado, Alan, thank you very much.
So yeah, hello, my name's Alan Trevenna. I'm from Jaguar Land Rover and I'm the audio technical specialist within the infotainment team. So my role is to be responsible for the audio quality of the sound systems from a reproduction perspective across Jaguar, Land Rover and Land Rover products. I guess a quick bit of background, I'm quite new to JLR, Jaguar Land Rover. I've been about a year, just over now, with the company. Prior to that, I worked in automotive in Detroit for suppliers, supplying systems to the big three, so GM, Ford and Chrysler. In addition to that, worked in a lot of consultancy on subjective evaluation of car audio systems as well. And again, the challenge here is how do you robustly evaluate something that you can't do double blind, you can't do under controlled conditions because you've got to drive the car's got to be in motion. The noise factors that control the outcome of a listening test are slightly strange. So anyway, for car audio, first thing, what is automotive audio? And it conjures up in a lot of people's minds the traditional lots of big subwoofers, lots of big speakers, boy racer. I'm from Essex, so Southend seafront kind of, or Brighton seafront, I guess, if you're from that part of the country. But you know what I mean. It's very, it's fun if you're 16. There are some excellent systems that are created in the aftermarket. There are some good competitions, but from what we're coming from, it's not really all about simply being louder with more bass, more speakers. It's an elegant system that we're trying to do here. So the goal of an automotive audio system is to accurately recreate music as the artist intended. We're not trying to suggest that I know any better than you the music you'll like and the way you'd like to hear it. What I do know is that the artists that sell records by the million have actually found a way to already satisfy you. So if we can recreate that experience, we've got a target now. We've got a very good shot at satisfying your experience for music that is across the whole range of genres. That makes sense. The other interesting thing about automotive audio is you don't often see the loudspeakers and the components. So if I go back to that picture here, you know, everything's on display. So not only is it going to sound amazing, of course, because you can see all the speakers, but everyone that sees the car is going to think the guy that put the stuff is just brilliant and, you know, must have spent a lot of money on this, and money equals quality, yeah? Right. So car audio, and I've got some components here and we'll talk about it in a minute, is mostly hidden. All you really see as a customer in a car is a speaker grill and a badge and whatever we present to you through the display. So it kind of frees us up to do some creative things behind the scenes. I don't care how pretty it is. What I care about is it's acoustically correct, it's doing the right thing, it's electrically efficient, etc., etc., etc. Before we go into that, I'm going to go bit of background, starting with what is car audio and where did it come from? And I've been doing a bit of research on the history of this stuff. It's quite interesting. A guy called William Lear invented the first radio designed specifically for the car. People were putting radios in cars prior to 1920, but no one had done one, created one that was intended for the vibration characteristics that you would find in a vehicle. So this is quite an incredible guy, really. He went on to be quite instrumental in 8-track. He invented things like autopilot, the Learjet, some pretty significant things, you know. So he got a patent and ended up selling his patent to a guy called Paul Galvin, who went on to sell this product from his company, Galvin Manufacturing, as the first proper mass-produced car radio designed specifically for cars. And he was quite clever in his naming it. Motor for cars and Ola for sound. It was called the Motorola and was the founding product of Motorola. So I don't know. I think that's pretty cool. But there's a picture of it there, and you can see the main radio unit, the speaker, and then the remote control that allows the driver to control the radio, tune to different stations. This is a copy of his original patent from 1934, and again, I haven't got a very good resolution copy, so it's hard to read the details, but again, a lot was going on back in the 30s trying to bring content into a vehicle, and it was really the first time that any vehicle occupant was able to do anything other than drive. So it's the precursor to everything that we know as in-car entertainment today, from navigation, telephone, the whole lot. This is kind of where it all started, because this was the first time you weren't just driving. Not a lot happened in the 40s. There were some other world events that kind of kept most people's attention. So in the 1950s, we had first FM radio from Blaupunkt, and the first radio that would allow you to actually automate the search function. Prior to that, it was just a rotary knob and you had to manually tune to a station that happened to have strong signal. And then it gets quite interesting with this Chrysler Highway Hi-Fi. Now, this was a record player designed for in-car use, 7 inches, and 45 minutes of content. They were made specifically for the vehicle. But now, you know, first time again, we're starting to see your own content being brought into the vehicle. No longer is it just, I want to listen to whatever's on the radio. I want to listen to specific bands, specific artists. And it truly was a interesting product. They only sold it for about 6 years, which sort of speaks to its, well, how much of a good idea it really was, I suppose. But it's quite interesting. You can't read what it says here, but I'll tell you what it says. Highway Hi-Fi phonograph provides the music you want wherever you go. It's another Chrysler Corporation first. Highway Hi-Fi gives you the finest tone reproduction even on rough roads. A special counterbalanced pickup arm and shockproof case ensure unimpaired playing. Conveniently located in the instrument panel, the Highway Hi-Fi record player slides in and out easily and can be operated without taking your eyes off the road. I'd love to try one. In the 60s saw the introduction of the first solid state radio, so absolutely no vacuum tubes. And then, yeah, we started to see 8-track pop up. And this was quite interesting. This was about the same time it was popping up in the consumer world as well. So initially Ford with Mustang, Lincoln and Thunderbird had 8-track players in the cars, and this was the first time that you could actually take content that you could play at home and play it in your car. So the Chrysler Highway Hi-Fi, you couldn't do anything with these discs outside the car. You were buying content specifically for use in your car. And I don't think we'd put up with that today, let alone in, you know, the 1950s. So this is really where 8-track came from, and by sort of 1967, everyone had 8-track players in the car. 1968, first stereo radio. Again, up until this point, it was all mono. And, you know, single speaker, not brilliant experience from an audio quality perspective, more content facilitating, bringing content into the car. And here's the 8-track in an AMC vehicle, and I believe AMC ended up being part of Chrysler and died, and etc., heritage-wise, but I'm not brilliant at. There's a lot of American car companies that seem to exist and disappear. So 70s, of course, cassette. And this kind of really changed everything. This is when you started to see all the big aftermarket head unit manufacturers come online and say everyone's now making mixtapes, they're generating their own content, so Alpine, Pioneer, Clarion, all these guys, and we start to see what we would resemble today, a system that's got a brand and audio experience associated. And honestly, I don't quite remember the Alpine Lamborghini, but I'm told by a lot of people that it was promoted a hell of a lot, and it's a very, very famous advert. And again, this the system that Alpine did put them on the map back in the 70s. 80s got more interesting because now we saw the first actual branded premium audio system. So in 82, Bose Delco, which was General Motors' electronics division at the time, who made things like head units, and General Motors worked together, and this was the first time you had a company that worked on audio talking about where shall I put the speakers, how big should the speakers be, things like that. Up until this point, it's all been about the head unit, all been about just getting that content into the car. So a lot of money was spent, not only on the engineering, but on the promotion of this system, and that paved the way for premium branded audio as we know it today, and as we'll listen to downstairs. So at the time, in 1982, Bose were already advertising and promoting their systems. And I mean, we recognise some of these magazines today, you know, Car and Driver, Motor Trend, Popular Mechanic, Road and Track. I mean, this is big time stuff that they were using, you know, 20 odd years ago, 30 years ago. So interesting. Since 82 to now, a lot's happened. Bose are really, really common. We see Bose in a lot of OEMs in North America, in Europe. We see things like ELS, which is a Panasonic system in Acura. Elliot Shiner was the record producer, and the ELS system was DVD audio, 5.1 surround sound, endorsed by record producer, so ties to the artist's intent, back to what I talked about at the beginning. We've got Boston Acoustics in Chevrolet, previously in Chrysler. We've got JBL in lots of Toyotas, Hyundais, Kias, that sort of thing. Wofford Fosgate, more of an aftermarket brand, but you get them in a lot of North American cars like Acura and Nissan. Alpine, back to the Lamborghini. Alpine is now in Jeep, Chrysler, Dodge. Bowers and Wilkins, just launching in Maserati. Don't know if anyone's seen that. The 7 Notes advertising campaign. Lexicon. Interestingly enough, Lexicon in Hyundai and Rolls-Royce. Denon in Citroën. Beats by Dre is an interesting one because they're pouring more money into promoting branded premium audio than most other OEMs and suppliers. So while their sonic goals might be questioned by some, they certainly have the endorsement of a big chunk of the record industry and artists, and you know, you've got Alicia Keys at the Super Bowl saying music as the artist intended, Beats by Dr. Dre. It's hard to communicate a stronger message to the consumer than that. So yeah, quite an interesting company. Naming Bentley, of course. Fender in Volkswagen, and again, this is interesting. This is the first time we start to see a company not associated with hi-fi starting to brand an audio experience in a car. Again, everyone's got similar goals, but Fender don't really make loudspeakers. They make guitars and some guitar amplifiers, I realise that, but they're not a hi-fi company. But they've got ties to the music, etc. It's just, again, different slant on approaching this. And then Jaguar Land Rover, our brand partner is Meridian. That is what we're going to listen to in the car downstairs following the talk. We've got a surround sound system in the new Range Rover. We'll go and demo that. So basically, from 1982 to now, everyone's jumped on the bandwagon, and branded audio is really important. Hence we're here, hence we're employed, or at least I'm employed. And yeah, it's a really exciting field, and it's quite new. Still a lot of things are happening. In 2007, Audi changed the game a little bit by launching the Bang & Olufsen sound system, and at the time, it was the most expensive premium audio system you could buy. That's $6,300 for the audio upgrade, just for the sound system. Crazy amount of money. I mean, in America, the A8 is going for about between $80,000 and $100,000. So it's, 6% of the purchase price, but still, that's just bucket loads of money. And what do you get for that? Well, you get distinctive styling, you get tweeters, the acoustic lens that pops up out of the dashboard. But really, you get to show off to your friends in the golf club. And it's defined a whole new segment for branded audio. And since then, we've got Bang & Olufsen and a whole bunch of other cars. We've got the new Mercedes, which is launching with Burmeister. Again, in that super premium segment, that really expensive segment now. And the Jaguar car, or the Land Rover vehicle, I was really trying to get this one to bring, and I kind of fell through at the last minute. We've just launched 3D surround, or surround sound with height, in the Range Rover. It's the same car as the car that's downstairs, but it's the system up from that one. And it's our most extreme system we've ever done. So in this system, it uses this amplifier, which is a 24-channel amplifier, and happens to be the biggest and heaviest module in the car. 29 loudspeakers, which is the highest number of speakers of any production vehicle on the road anywhere in the world, as far as I'm aware. And as you can see, this picture is showing speakers in the seat back here as well. So these are loudspeakers. So this is a personal centre channel for the rear seat. And you might argue, why do you need so many speakers? That's just a little extreme, isn't it? And it is, but if we only cared about the driver, we could do this with 8 speakers. But what we want to deliver here is the same experience in every seat at the same time. So to do that without, so front and rear seat have the same, left to right have the same, your centre image, your sound stage, your imaging, ambience, everything is there. That's where the speaker count comes from. It's also got 4 speakers in the headliner. So it's this surround with height. So we've got elevation as well. And I'm aware that there are more cars launching with similar algorithms in the next 12 months. But yeah, it's a really interesting system from that perspective. Okay, so that's kind of a bit of background, why car audio is fun and cool and interesting. Now talk a little bit more about the components and the bits that make up systems. First of all, the speakers, and I've got some examples of loudspeakers on the table. You feel free to come and have a look. These are all neodymium speakers, so we've got the Neo here, which is quite expensive, so please leave it on the table. But some key things that are different in an automotive speaker versus a hi-fi speaker. First of all, you will always see the Spider completely seal the voice coil. So you've got a clean area, we're eliminating particulate rubber bars entering the gap. Some hi-fi speakers, you often don't have that. You don't want that sort of acoustic impedance, that air load around the voice coil if you can help it, but we'd rather have that than have dust and dirt and stuff on the voice coil. So yeah, I expect most people understand the mechanics and anatomy of a loudspeaker. There is nothing special about our speakers other than the fact, like I said, that they've got to be durable from a reliability perspective. So we expose speakers to extremes of temperature, humidity, vibration, chemicals, water, dirt and dust, etc., etc., etc. And to be honest, even if the speaker gets covered in things that are undesirable, customers don't care, and if it sounds bad, they're still going to bring the car back to the dealer. And that costs a hell of a lot more, just that one trip, than any one of our speakers. So the cost of failure of a loudspeaker in a car is significantly more than any of the components on their own. From a performance perspective, our goals are slightly different as well. I think I've got a slide that will talk about this in a bit as well, but you never listen to speakers on axis to start with. So frequency response is really important, but on-axis frequency response, well, actually power response and off-axis response are probably more important than on-axis frequency response for most of our loudspeakers. We also have the luxury of knowing exactly which amplifier is going to be connected to them. So I know how many volts are going to the speaker under worst case conditions, therefore I can understand its excursion characteristics, when the surround and the spider are going to snub, if there's any chance of the voice coil bottoming on the back plate, so we can make these things as small as possible, as light as possible. The roll surround is as small as possible, but not too small, because I know exactly the size of the amplifier. From a durability perspective, like I said, there's a lot that goes into making sure the loudspeakers are reliable and safe. So from temperature, thermal, like I said, dust, drop test. So if you drop the speaker, it either has to work perfectly or look extremely damaged so no one can put it in a car. No halfway house, because then we might get misaligned coils being put into cars and no one knows the difference until customers start bringing the cars back. And there's some interesting things that happen when you expose loudspeakers to these extremes. So thermal endurance, long-term exposure to high and low temperatures, and this is the effect on resonant frequency of a random speaker. I'm not really going to name and shame any of our components or competitors, but you can see a slight shift. It's not significant. I mean, these lines are 5 Hertz difference, so that's about 2 Hertz shift in resonant frequency, pre and post thermal endurance, so 1,000 hours of high and low temperature exposure. Vibration, shock and humidity, again, similar sort of thing. Door slam test. So 5 samples, we do a significant amount of simulated G-force shock tests that would simulate a door slam. What happens to the suspension components and therefore effect on resonance. Effect of dust, so here we're looking at moving mass. We've added a whole bunch of mass to the cone essentially, and the moving assembly is heavier, resonance is lower. High power, so it's not a significant difference here, but just, we'll run the thing at full power for a significant amount of time. Thermal shock, this is another interesting one. So now it's really quick. You go from 120 degrees down to minus 40, as quick as possible. And everything still has to function, still has to work. And we need to understand that pre and post, we're not going to get a completely different system. And if resonance shifts of a high Q loudspeaker to a point where it's now way out of its span, efficiency has changed, loudness has changed, the whole acoustics of the system have changed. Mechanical wear out, again, this is full excursion, maybe low frequency sweep, for example, just stretching all the suspension components and understanding what happens. I've got the same thing here for SPL, so this is sensitivity. And you can sort of see, the graph might be misleading. This is a dB between these two lines. So it looks like this is a really big deal, but what we're seeing is less than a dB change on sensitivity going through any of these same tests. So that's sort of high-level summary of loudspeakers. Like I said, come and have a look after the talk, and we can go through any of the subcomponents in detail or anything. The next sort of important part of the system is, where do we put the speakers? So packaging, location, positioning in the car becomes really, really important. So at high frequencies, directivity, off-axis response like we talked about, energy response are really important. So you'll see in the car downstairs, the tweeters aren't angled directly at you. So you haven't got the tweeter closest to you pointed at you in the driver's seat. It's pointing more across car line. So what that's really doing is that's delivering the highest SPL on axis to the guy furthest away from it, and the guy closer to the speakers off axis. So we can balance the system just by positioning loudspeakers. At low frequencies, it's interesting. Now this graph is showing, well, to this first dip here, the laser point doesn't work on these screens, so this first dip is 63 Hertz. So what this is showing is at 63 Hertz, there's a 20 dB difference in efficiency, depending on where you put a loudspeaker in the car. And this is to do with the modal distribution within the cabin space. And, 20 dB is not to be sniffed at. If we can get 20 dB of free gain, or we can hamper our systems, we have to put 20 dB of more power in to get the same output. We need to know this stuff. So at low frequencies, it becomes really important from an efficiency perspective, again, the location of loudspeaker. And it's not just about closest to the occupant is loudest. It's about understanding the acoustics of the cabin, and it's different whether it's a saloon car or an SUV, minivan, that sort of thing. The other thing with integration is it's important to note that when we think of speakers in cars, I mean a speaker drive unit. What's on the left, in my mind, is not a speaker, that's a speaker in a box. And maybe that's just being pedantic at this point, but we never have the luxury of having 2 or 3 drive units on the same axis, time aligned, and everything's, sums perfectly at a particular listening point. Forget it. So we've got to be a bit more creative. So what's on the right is showing a three-way system, just like the one on the left. But the bass driver is under this big grey grille. Then you've got mid-range and tweeter. So not only are they positioned differently left to right, but they're angled in different planes or different orientations as well. So through DSP and the amplifier, that will give us some ability to add time alignment and time delay, as well as, again, off-axis performance of the loudspeakers, we can come up with an experience that sums properly at the listener location. And is this everything I've just said? So yeah, okay. Multi-way systems as well. Why do we need more than a single speaker in a car? Why do we need a 2-way? Why do we need a 3-way? So other considerations for packaging in cars. If we simply put full range speakers in the doors, when you sit in the car, your knee is going to be in the way. I'm not trying to be overly simplistic here, but that has a big effect not only on what you hear, but what the guy on the other side of you hears. And you're getting a lot of the cars that have got maybe 6 speakers. So in the back doors, there's only a mid-range or full range in the doors. You can sit there and you can move your knee around, and the system changes completely. So tweeters help us overcome that. Not only do they break up elegantly, but now it's stable with occupant in terms of the sound field. Like I said, the 3D surround system in the new Range Rover, 29 speakers, so that's the other thing, is when we've got that many speakers, finding places for them becomes a challenge. And So we're always looking at smaller, thinner, lighter speakers that can give us efficiencies. There are a lot of concept cars running around with flat panel loudspeakers, electrostatic loudspeakers, all sorts of things like that. I'm only aware of one or two proper full-blown OEM production systems. Toyota and Fujitsu did some with NXT panels in the headliner a few years ago in Japan, and they work quite well, but there's an efficiency problem here, and it's overcoming how loud do we need those speakers to be on par with the rest of the sound system versus how much power have we got available and when do they start to distort. So we yet to see those sorts of technologies really become properly embedded as a robust automotive solution for loudspeakers. So we're still with moving core transducers, frankly. Right, amplifiers. Like I said, this is our biggest amplifier, 24 channel, marketed as 1700 watts. And unfortunately, it's not the one downstairs. The one we got in the car downstairs is a 16 channel. It's its baby brother, 825 watts. And again, these are all a hell of a lot more than an amplifier. It's an amplifier. It's all Class D. It's got a lot of DSP. It's got all of the safety elements of diagnostics, what happens at low voltage, how do we make sure that the system stays functional under all these extreme conditions that we would never really expose or want to expose an amplifier to. So we're pretty much exclusively Class D for all of our premium amplifiers at Jaguar Land Rover, simply because we get the efficiency improvement for size, and when we're trying to put 24 channels in a car, we'll be laughed out of the room if we want to put anything bigger than that in the car. So size, efficiency, and then therefore a heatsink that isn't enormous is what leads us down the Class D route. But honestly, we continue to fight with electromagnetic interference. AM radio reception continues to be a problem, and there are a lot of chipsets that switch, but when you've got 4 tuners in the car that are scanning for things in the background, which one of those 4 tuners do you want to switch away from? So it's not as simple as only having 1 tuner. So there continues to be challenges. It's absolutely not perfect yet, but certainly from a state-of-the-art perspective, Class D is what Jaguar Land Rover and all of our competitors are putting in vehicles. Like I said, the amps do a hell of a lot more than just amplify audio. So equalise the loudspeakers to the cabin, provide surround sound. So we're going to be listening downstairs to the Meridian surround sound system in the Range Rover. So that has Meridian Tri-Field, Dolby Pro Logic 2 and DTS Neo 6 in there, switchable on the display, so you can experience the 3, as well as stereo. And stereo turns off the centre channel, and you go back to what it would be if we had no centre channel, which is horrible. It's not horrible, but centre channels are really nice. And discrete surround decoding, so put a DVD in and we can play 5.1 discrete with the system, as well as gain. And that's an interesting one, gain. So we can change the volume knob on the head unit in the car. What you're actually doing is changing the gain in the amplifier, and everything else stays at nice, robust signal to noise ratio all the way through. Balance and fade, and then all of the foreground sources, so all of the non-entertainment events that occur in a car have to be managed somehow. So you make a phone call, navigation talks to you, you want to do some sort of speech interaction. Amplifier again has to get its head around all of that and understand what's more important, what should I do, what shouldn't I do, what should I turn up, what should I mute, etc., etc. So system calibration, this is our sort of another way of thinking about what is EQ and how do we approach sound system equalization. So we start off, we understand a speaker. So I've got a speaker, it looks a bit like that with some more stuff in the middle. It's got a frequency response, brilliant. I've spent loads of time on it, it's smooth, it's flat, it's 20 to 20 hertz, it's the world's best loudspeaker. I'm going to put it in a car and, well, I'm going to make it loud stick it in the car, and actually that's going to bolt it to a panel that is vibrating. It's made of thin sheet metal. It's got losses throughout, so my brilliant speaker all of a sudden has got no low frequency performance, has got some horrible resonances in the mid-range, all because it's stuck on this loose tin metal panel as a box. And then we're going to go back to the acoustic transfer function. So that graph I showed you with the 20 dB at 63 Hertz, well, we're going to subject the loudspeaker to that as well. So not only we've got losses because of the mounting, or baffle factor as we would call it, we've also now got the effect of the transfer function throughout the cabin. But if we can manage all of that through some clever DSP, equalise that and correct for that, we should have a brilliant sound system. Sort of. Because the problem we've got is we've got a hell of a lot of loudspeakers in the car, so it's not just one. And each one of those loudspeakers has a different characteristic and a different mounting condition, different losses due to what it's bolted to, the grille that's in front of it, how much of that grille is actually a grille and how much of it is a door pocket, for example. And then all of these transfer functions to each listener. So it's actually, in this case, 15 speakers times the 4 occupants. So all of a sudden it's a mammoth task to put this system together. And then, like I said, we start blending in all of these foreground events, the speech, the telephone, the navigation prompts. Once we've got all of that, we now have an equalised system, and that's the DSP that sits inside the amplifier. And, you know, I used to work for a company that does a lot of aftermarket amplifiers. And when you start to go through this with those guys, they're blown away with the capabilities of our typical OEM production automotive amplifier. And all of a sudden they want these in their car so they can start playing with all these settings and toys. It's great fun. You could waste hours playing around with this, but it's so sophisticated, more so than we find in any consumer product from a DSP shaping capacity for in-car. Okay, got a few slides to talk about surround sound, and this becomes, again, another interesting challenge we've got in cars. So, first of all, this is a picture of a 7.1 setup from someone who thinks they've got a good answer for where speakers need to go. Brilliant. We can put it in a room, you sit in the middle, everything sounds really, really good. Okay, cool, let's put it in a car, and actually, everything lines up. I mean, the left, right, centre speakers are about right, the side speakers are fine, everything's brilliant, but the problem we've got is you don't sit there, do you? And actually, you've got a different problem as well, that you sit in 4 places. So, surround sound in cars, using the algorithms that are adopted and developed for home, is something that is completely different, and we're actually using these things like Dolby Pro Logic, for example, in a way that it was never really intended. So how do we approach this? So what I'm talking about here is a rendering engine that is the adaptation of that surround matrix to vehicle-specific speaker layout or audio architecture. And that rendering engine will encompass some blending. So say, for example, we map 5.1, 7.1 system into a car. I get in the back, all I'm going to get is an earful of surround, which is frankly unacceptable. So this interchannel blending, I actually want to put some of the dry front content, left channel, into the left surround a bit more, and change the way the algorithm is distributing content around the car so that you can have appropriate experiences front to rear. You'll hear this downstairs in the car. There's surround in the car, but in the back you're not swimming in surround compared to the front. It becomes even more interesting when we do talk about 3D, because if I go back to here, this is an 8-channel output, so 7.1 out of the 2D surround matrix. In 3D, we've now, here I've got 11.1 because I've got 4 headliner speakers as well, 4 height channels. The new Dolby, the new DTS Neo X 3D algorithm has got 4 height outputs. So again, this inter-channel blending and this the way we're going to mix these speech channels together so you can get an adequate experience in all seats becomes really, really important. Okay. So we talked about loudspeakers, we talked about amplifiers, we talked a little bit about DSP. Now I'm sort of coming on to whole system level measurements and how do you know if a system is any good? So this is these are frequency response measurements of a lot of vehicles, and you can see that they vary quite widely. So on the vertical, that's 5 dB per division. So we've got 10 dB on average difference. And if we were to kind of look at max and min, that's really what we get measuring a lot of premium audio systems. With some outliers, and this is all with the caveat, a good car sound system isn't designed to sound good stationary, it's designed to sound good when you're driving it. So if the car is really, really noisy, it will be designed so that whilst you're driving it under those noisy conditions, any masking effects of the engine, the road noise, the wind noise, the tyre roar are taken into account as part of the audio equalisation, and therefore you get a balanced experience. But typically what you see in the middle is an automotive audio frequency response, what you'd expect to find in a car. And if we be a bit more smooth about it, the green curve is a somewhat standard frequency response for in-car sound systems. So what you see is a rising high frequency response. Again, a lot due to the masking effects of road noise and tyre noise and that sort of thing. And then a roll off at the high frequencies as well, because at high frequencies you're talking about total power response now, not just on-axis frequency response. And if I was to maybe highlight a few of the good systems within that whole bunch of measurements, and what I mean by good is subjectively agreed that they sound really good, we see that the target curve works quite well. So if we say, how do we know if we've met the frequency response? This is a good way to give us that first stab of getting there. Nothing's perfect, as you can see, the high frequencies things are different, but it's a really hard thing to make an engineering judgment that the sound system sounds good on the road under these noise conditions when your focus is on the road as well as the audio, etc., etc. Other objective measures are loudness. And this is really interesting. I think I can be so bold as to say there's almost no correlation between advertised power and loudness. I've been in systems that are advertised at 350 watts that are louder than 1500 watt sound systems, for example, and it really is advertised power, marketing watts, all that stuff. We can kind of leave that to the people that need to write brochures. Loudness, perceptually relevant loudness with an amount of distortion that is controlled and understood, not turn it up to full volume and see how loud it is the kind of measure that, again, gives us a level of quality and consistency, product to product, and that sort of thing. From a subjective perspective, structured subjective listening tests. What I'm showing here is a common subjective analysis sheet with 63 attributes, if you count foreground and background listening on here. And you never ask the listener, do you like it? Frankly, that's the wrong question to ask a trained listener during a subjective evaluation. There's a target, we agree on this reference sound. The question is, do you meet that? Do you not? With the specific attribute of spectral, narrow band peakiness, specific piano notes jumping out at you, are you the same as the reference or are you different? If you're different, are you different to a point that it's unacceptable and annoying? Are you different that you can detect it but you can live with it? And we can start to break down this subjective, almost emotional experience into engineering terms that we can feed back to the guys that are doing the acoustic calibration, the tuning, the equalisation, that they can say, oh, well, I know that peakiness means narrow band peaks, and if I look at my frequency response, I do some listening, I can zone in, and etc., etc. And by having really discrete attributes that are focusing on a specific question, we can manage the bias that comes in when I get in a Maserati with the Bowers and Wilkins sound system. I'm blown away that it's a Maserati, it's a fancy car, I want to show my friends, this is brilliant, the sound system's great. But actually, when I ask myself these specific questions, I can't hide from the fact that it does or it does not meet that reference experience. And that reference is what we agree on. Idealised listening room, ITU 775.1 or whatever, we agree is the right sound that we're targeting. Okay, how are we doing? Cool. So, in short, that's a quick overview of automotive audio as I know it and as we approach it at Jaguar Land Rover. I can talk about the car we have downstairs. It's a 2012 or 13, 12 Range Rover with Meridian surround. It's got a 16-channel Class D amplifier. It's got three-way speakers in the front and rear doors with coaxial centre channel and coaxial surround loudspeakers, and the subwoofer is under the driver's seat. Like I said earlier, we can go and sit in the car and you can experience Meridian Tri-Field, the Dolby Pro Logic setting and the DTS surround settings, and sit in the front, sit in the rear and see how the experience changes. And the car is really, really good. It's different front to rear, but it's an equivalent experience. It's not the same experience. And this is one of the coolest things about car audio, is that the guy sitting next to you is having a completely different experience to you, yet you're only that far apart. And that's kind of magic, and you don't really get that in any other audio playback environment when the relative distance, I'm getting too excited now, between the listeners and then distance to the loudspeakers is really big. But here, you know, you're always in the near field of one speaker, if not multiple loudspeakers, and you're often closer to some speakers than you are to the guy next to you, even though he is next to you. And so car audio is cool, it's crazy, it's interesting, there's a lot of technology that are going to make things even better than we have today. But the systems that not only Jaguar Land Rover developed, but you know, premium systems today are excellent. So a lot to be excited about. We can talk about questions now. We've also got some more guys from the team at JLR here, and we can all talk about the car standing around downstairs as well. But yeah, thank you very much.
First, let's see the West End. I'll show you to my bedroom. Liking this American boy, American boy. Take me on